Alright guys, we're going to do a little recap on section 5.1, which is on functions and their inverses. And some things to remember: only one-to-one functions have inverses that are functions. You could find the inverse if it wasn't one-to-one, but that wouldn't be a function. So what they're going to ask you for is the function they give you one-to-one? If it is, then you find the inverse of that. So first of all, we got to figure out if we have a function. So if a graph is a function, it would pass the vertical line test. So if you look at all four of these graphs, I drew a line. Remember, that passes the vertical line test. I drew a parabola. That would pass the vertical line test. I drew a cubic function, the blue one, and that would pass the vertical line test. And so would an absolute value function, the very last one, that would pass the vertical line test. But not all of them are one-to-one. They're all functions, but some of them have y's that are repeated, which would mean they are not one-to-one, which would mean they wouldn't have an inverse that's a function. So how do we figure that out? Well, if something's a function, your x's can't be repeated, and it passes the vertical line test. That goes way back to the beginning of this year. We looked at, is it a function or not? And we looked at some different graphs that were and some that weren't. And as we noticed, the x's weren't repeated in the functions, and they all passed the vertical line test. So to find the inverse, only one-to-one functions have the inverses. So how do I know that it's one-to-one? Well, not only are no x's repeated, neither are the y's. So if it's going to be one-to-one, your x's and your y's are not repeated. To look on a graph and figure it out, it would pass the vertical line test and a horizontal line test. In other words, if I were to draw a horizontal line, it could only pass it once, just like the vertical line did with my function test. So as we look through problems today, I'm going to do some of the even problems in this section so that you'll get some idea of how to do it. The first thing we're going to look for is it a one-to-one function? And then if it is, find the inverse. If it's not, you're done. Just say, no, it's not one-to-one, and you can go on to the next problem. So the very first one, f of x equals 7 minus x, that's problem 56. So if I graph f of x equals 7 minus x, here's what the graph looks like. It's a function. I know that because it's written as f of x. So what I want to see is it one-to-one? And it is. No matter where I were to draw a horizontal line, it would only cross this graph once. So this particular problem is a one-to-one function. So now I'm going to find the inverse. So I take this problem, if I can get my pen to work, and I write it, instead of writing it in function notation, I'm going to write it in as y equals 7 minus x. So same thing, f of x and y can be used interchangeably. So this is my original problem. So to find the inverse, I'm just going to change my x's to y's and my y's to x's. So this becomes x equals 7 minus y. Now all I have to do is solve for y. So I'm going to add y and move it over here, and I'm going to subtract x and move it over here, and this would be the inverse. I change my y's to x's and my x to y, and then I solve for y. So to write my answer, I don't want to write it y equals, since my original problem was in function notation, I want to make sure my answer is also in function notation. So the inverse function is 7 minus x, and that would be my answer. Now, if you'll notice something here, that's what my original problem was. Doesn't happen often, but it does happen in some cases that a function is its own inverse. All right, 58, f of x equals 5x plus 8. Let's look at that on the graph. All right, so here we have 5x plus 8. We look at it. Again, every linear equation is going to be one-to-one. The ones that aren't are going to be like your parabolas and things like that. So this is also one-to-one. So what I'm going to do is I'm going to come over here. I'm going to write it as a y equals 5x plus 8 to start with. So the inverse of that would be x equals 5y plus 8. Now just solve that for y. So I'm going to subtract 8. X minus 8 equals 5y. Divided by 5. So now I've solved for y. X minus 8 over 5. So I'm going to write it in function notation. The inverse function is x minus 8 divided by 5. So when my original problem is 5x plus 8, my inverse is x minus 8 over 5. If you were to graph both of those on a graph, let's see what that would look like. X minus 8 over 5. I'd need to put parentheses here. X minus 8 divided by 5. And I'm also going to graph the line y equals x because you're going to see something that's going to happen here. So this is 5x plus 8. Here's the inverse. and take a look what happens. This is the line y equals x that you should be familiar with. So if you look, the blue line, if you flip it or reflect it across the line y equals x, it will become the red line. So that shows that they are inverses of each other. They're just flipped directly across that line. All right, let's take a look at one that's not a line, maybe this rational function here. So the original problem, this one's going to be probably one of the toughest ones that you will do, are your rational functions that we just finished in chapter 4. So y equals 5x minus 3 over 2x plus 1. Whoops, sorry about that. And so what I'm going to do is I'm going to change my y's to x's and my x's to y's. And I've got to solve for y. Problem is I've got two y's, so I'm going to end up having to get them together and then factor and things like that. So the first thing I need to worry about is this has a fraction, so I want to get rid of that fraction. So multiply by 2y plus 1, and you've got to do that on both sides. Over here it cancels, so over here I just have 5y minus 3, and over here I have x times 2y plus 1, which becomes 2xy plus x. X times 2y is 2xy, and x times 1 is x. So I'm trying to solve for y. So what I'm going to do is I'm going to leave the 2xy here. I'm going to move this 5y to the left. And I've got a negative 3 on the right, and I'll move the x over there to the right. So both of these have y. Neither of these do. I'm going to come up here. So on the left, what I'm going to do is I'm going to factor out a y. Since they both have y, it's a common factor. I'm going to factor that out. So now I have y times 2x minus 5 equals negative 3 minus x. And then all I have to do is divide by 2x minus 5 on both sides. So that cancels, and my answer is y equals negative 3 minus x over 2x minus 5. And I really should have written it in inverse function notation. The inverse function is negative 3 minus x over 2x minus 5. Now, you may see it in the back of the book. This is a correct answer. You may also see it with every single sign changed. Like, or it could be 3 plus x over negative 2x plus 5. If every single sign is different, that's an equivalent expression. So it just depends on how you solved it as to which one of these two you'll get, but know that both of them are correct. All right. We could also have some cubic functions that we were asked to find the inverse of. So if y equals the cube root of x minus 8, then if I switch that, it'd be x equals the cube root of y minus 8. So to solve this for y, I'd need to cube both sides. So I'd get x cubed equals y minus 8, add 8 to both sides. So that is the inverse function for this one would be x cubed plus 8. And finally, problem 64 is a cubic function. So this one is y equals x plus 5 cubed. So if I switch it, it's x equals y plus 5 cubed. And if I wanted to solve this for y, I would need to cube root both sides. So I get the cube root of x is equal to, when you cube root a cube, it just removes that symbol. So you get y plus 5. So it would be the cube root of x minus 5 is equal to y. So my inverse function is the cube root of x minus 5. And that's it. So good luck with your inverses. If you have any questions, please let me know. Problems tonight from section 5.1 are going to be, let me go ahead and go over that, page 389 to 393, which I don't think it's really on all of those pages, but that's the pages for section 5.1. It's problems 55 to 75 odd. 11 problems. Go ahead and get those done tonight so you're not trying to do them all at the last minute. Stay on top of your work this chapter, and I'll see you tomorrow.